We're finishing section 11.2, working through simplifying some radical expressions. So the key thing is, for example, here in problem A, you want to be able to rewrite any whole numbers as a power. So you want to break them down as far as they can. So in this case, 256 becomes 2 to the 8th power. From there, you can separate it. The key thing you're looking for is you want any powers that you have to be a multiple of whatever root you have, because that means they will be able to divide fairly easily. So here, the first thing we're going to do, we're going to use the quotient property. We're going to break apart that quotient so that it becomes the 4th root of 81 over the 4th root of x. So we're going to simplify. The 4th root of 81 ends up being 3. Now, we're going to be doing some rationalizing of the denominator. So when you rationalize the denominator, the key thing you're looking for, you want to multiply by something that will have a power that is easily reducible based on what your root is. So in this case, our denominator is the 4th root of x. So under that 4th root, we want an x to the 4th or an x to the 8th, something that will be nice and easy for us. So that's why we're multiplying by the 4th root of x cubed. That way in the denominator now, we've got the 4th root of x to the 4th, which just will become x. So simplified, this becomes 3 times the 4th root of x cubed over x. So again, we just talked about this, why we used x cubed, the 4th root of x cubed, to rationalize the denominator. So when we think what factor would we use to rationalize the denominator of the 5th root of 4y cubed? So we want to multiply by something that will give us a 5th root. So ultimately, we can rewrite this 4 as 2 squared. So ultimately, essentially what we want then is 2 to the 5th and then y to the 5th. That way, those will reduce easily for us. So what we want to multiply by, if we've got 2 squared, we'll need to then multiply by 2 cubed. We've got y cubed, so we'll need to multiply by y squared. So essentially, we'll want to multiply by the 5th root of 8y squared, because that will get us to a denominator that we can simplify, that we can rationalize. So here we want to break this apart. So we're looking for, is 216 a perfect cube of something? You can check that on your calculator. And it is, in fact, a perfect cube of 6. So I'm going to break apart this product into its different pieces. So we've got the cube root of 6 cubed. We'll have the cube root of x to the 12th and the cube root of y to the 15th. So from here, I think it's easier to actually rewrite it in terms of the powers. So rewriting it this way, we can see how those different fractions are going to simplify. We'll end up with 6 times x to the 4th times y to the 5th. There is our simplified answer. So the next problem, again, we want to break up our fraction. So we've got the 4th root of 16 and then the 4th root of x to the 14th in the denominator. So numerator is pretty easy. It'll simplify fairly straightforward. So we want to actually break apart that denominator into something that will divide evenly into that 4th root. So we can break it up into x to the 12th and then the 4th root of x squared, because those powers will add to the 14th. From there, that x to the 12th, the 4th root of that, is the same thing as x to the 12 over 4, which is just an x cubed. We still have that 4th root of x squared. So now we want to rationalize our denominator. So again, since we want a power of 4 in that under that square root, we'll end up multiplying by the 4th root of x squared. That way, we'll end up with x cubed times the 4th root of x to the 4th, and that will just become an x. So our final answer would be 2 times the 4th root of x squared in our numerator over x to the 4th. So we can rewrite these using some models, plug in some values, and see what answers they're looking for, essentially. So in this case, we've got the buoyancy of a fishing boat in water depends on the volume of air it contains. We're given an equation. So first thing we want to do is rewrite it. So here they broke apart the 3 over 4 pi, and then that would be multiplied times v. Now we can separate out the root. You can use your calculator. The cube root of 3 over 4 pi ends up being about 0.62, and then we're still got the cube root then of v. So if we want to substitute in a value, we'll plug that in. You end up getting about 1.02. So then the radius is 1 foot. So here the surface area is a function of volume for a box with a square base and a height that is twice the side length of the base is S is equal to 10 times V over 2 to the 2/3. So we're going to simplify the expression and then approximate the model with the coefficient rounded to the nearest hundredth. So essentially we have S is equal to 10, and we can separate that division. So V to the 2/3 over 2 to the 2/3. We can break apart that 10 to become 2 times 5. So our numerator is now 2 times 5 times V to the 2/3 over 2 to the 2/3. So in doing that, now you can see we've got a common base of 2. So we can subtract those exponents. We'll have 2, this is technically to the 3 over 3 power up here. So subtracting 3 over 3 minus 2 over 3, we end up with 2 to the 1/3 times 5. So we'll have V to the 2/3. So this would be the simplified then. If you plug into your calculator the 2 to the 1/3 times 5, you end up with about 6.3 times V to the 2/3.